Hello friends, today we are going to describe a very important and a very interesting program. We have already studied the program to find whether a number is an Armstrong number. So in this program, we are just changing the program's concept to a little extent to print all the Armstrong numbers, within a specified range. If a user gives the lower range to be 100 and the upper range to be 999 or 1000 or whatever may be, all the Armstrong numbers which are falling within that specified range would be printed by this program. So the logic is quite similar to the Armstrong number checking program, but that logic is to be implemented in a somewhat different way in order to print all the Armstrong numbers, and not only checked whether the numbers are Armstrong numbers, and if a number is found to be an Armstrong number, that number will be printed. Other than that, no numbers will get printed by this program. So let us just get started with writing the program. Hash include stdio.h hash include math.h. Now we come to the main section. Declare some required variables. What are the variables which are required? See, we require a variable which is, say, the lower limit, say low, upper limit, say up. That is, these are the two specified values which determines the range. And then we take a variable I, that is the loop variable, and another auxiliary variable to store the value of I, and whether to change this I or j, that should be discussed later on. And then we take sum and another as remainder. For the remainder we take r. So I think these are the necessary variables to be taken beforehand while writing this program. So let us get started with writing the logic of the program. Suppose printf, we ask the user to print the lower and upper values of the range. Enter the range, new line, scanf, user prints, user inputs, %d, again %d, ampersand, low, ampersand, up. So user gives two values of low and up. That is, suppose the lower bound is 100, upper bound is 999 or 1000, whatever may be. So in this case, this becomes the low value and this becomes the up value. So we have to find whatever all the Armstrong numbers falling within the range of this 999. So whatever will be the Armstrong numbers, whichever Armstrong number are falling within this range will get printed as an output of this program. So let us now take an outer loop for dealing with this range. So that can be taken as a for loop for the sake of simplicity. For I is equal to the lower range, that is starting from 100, I less than equal to, we will not write 100 because we have assumed it to be 100. We will just write low. We will just write low here. I less than equal to up, I plus plus. So what is this? Our range is specified by this outer for loop. So we are going to calculate and check whether any number is an Armstrong number in the inside while loop, in the inner while loop, innermost to this for loop, and this outer loop represents this range, that is low to up. That is the range in which you have to find all the Armstrong numbers which are to be printed. So I is equal to low, I less than equal to up, I plus plus. We enter this outer for loop's first statement. What we will write? We will definitely take the help of this auxiliary variable j. We will definitely take the help of this auxiliary variable j and assign the value of I to it. Whatever is the value of I will be assigned to the j variable as soon as we enter this outermost for loop. Then j is equal to I, so this j will be now checked whether it is an Armstrong number. So we write, we have to determine the sum. So sum is to be initialized to 0. Now we come to the while loop. While j greater than 0, while j greater than 0, that means we will just go through the iteration process, inner while loop iteration process, as long as the value of j is a non-zero positive integer. So let us write the program in quite a similar method as we have shown in some previous class while we were dealing with this Armstrong number checking. And now we will calculate the r, that is the remainder, as this j percent 10. That is quite similar to the previous logic. This is nothing but the checking of Armstrong number logic. Sum will be calculated as sum plus pow r comma 3. Sum is equal to sum plus pow r comma 3. As you know that all the Armstrong numbers are determined in this logic, that is sum of the cubes of the digits are to be calculated, and we will try to match that sum with the original number. If that matches, if both of them matches the match, and then we infer that the number is an Armstrong number. So sum is equal to sum plus power r comma 3. We have included the math.h header file for using this power function, which is included in this math.h header file. So now comes the updation of j value, that is j is equal to j slash 10. Now j is equal to j slash 10. So the number will be divided by 10, and whatever will be the quotient will be put in the j value, so as to in this way we will just update the value of j. So after that, what is our task? We complete this while loop construct over here, and let me just wipe off a little bit of portion from the top so as to continue with writing the program. Excuse me for that. Now I will come to this line after the for loop, after the while loop. Now let us see whether this j matches with the original value, whether this sum matches with the original value. So see, if we will write an if over here, if sum is equal to, if sum equals I, because the original number is stored in I, and the sum will be calculated in this line. This sum will be tallied with this I in order to see whether this sum is equal to I. If this becomes equal, that is definitely we can conclude or infer that this I was an Armstrong number. So we will just get it printed. So in this situation, we will print nothing but %d \t, that is t means tab. In order to just print it in a very formatted way, we will just place a tab. You can place it or you might not place it. %d \t, there is the tab, and now we will print the value of I, because I is not changed. J is changed in the course of the calculations, in the course of the iterations, and I has not changed because we were definitely holding the value of I in the process. So this I will be printed. In this manner, the for loop is ended, and whichever I value becomes equal to the sum calculated in this while loop for each iteration of this outer for loop, that I will be printed as an Armstrong number found within the specified range. Suppose the first number automatically we will get as 153, because 100 will not be an Armstrong number, as you know. 101 will not be an Armstrong number. In this way, the program will go on, and till 153 we get the first Armstrong number, and that Armstrong number will be printed in the form of I. So that takes us to the end of this program. It is a very interesting program and a very important program for academics purposes. And we come to the end of this program and return 0 and then end the main section. So if you have any doubts or queries pertaining to this program, you can well post your doubts or queries in the comment section so that I can address them. Thanks.